Today we will start approximate reasoning, that is actually implication, that is rule based. Approximate reasoning. Here suppose we have rule based format for the fuzzy information. Rule based format means you have rules, if A then B, okay, first rule, second rule, if A dash then B dash, if A double dash then B dash, B double dash, like that. So, using that we actually approximate, suppose we have the first rule, we have if A then B, okay. So, if A is your antecedent and then B is your consequent, that means if x in A then y in B. So, if x in A is the antecedent and then y in B is consequent. Suppose rule 2 is if A dash or if x in A dash then y in B dash. Okay, I will write if x in A dash then y in B dash, second rule. So, whether you can use the information of rule 1, okay, to get the consequent of the rule 2. Okay. So, that means if I have the rule 1, if x is A or A bar, because fuzzy A bar, then if x is A then y is B bar. Okay, this you know, this is your implication, A bar implication B bar. If x is A bar then y is B bar, this is rule 1. And rule 2, suppose if x is A bar dash then y is B bar dash, okay, right. So, I was telling, so first rule is your if x is A bar then y is B bar, if pressure is A bar, temperature is this, like this some other is there. So, this is your antecedent, this is consequent. So, you know how to do this if you have this A bar, B bar, etc. in terms of fuzzy set, you know that. How you find this? If it is given A bar, B bar, x, y, because A is in x bar, B is in y bar, that is there, okay, universal set x bar and B bar in universal set y bar, okay. So, suppose this you have, so you can write that, you can find that. How you find? By relation R bar, okay, that you know how to find. R bar will be what? A bar cross B bar union A bar complement cross y bar, that you know, that means that relation matrix you know for this rule, rule 1, okay. I am telling now, using that information about that rule 1, whether I can find this consequent. You are understanding? Using the information of rule 1, whether we can find the consequent of this, means y is B bar dash if I can find, okay. So, our aim is to find B bar dash using this R actually, and we can do by, any idea? We can do very well, that is by composition. Composition means you have relation, so I can have this B bar dash is equal to A bar dash composition of R bar, where remember this R bar is, it is from rule 1, A bar cross B bar union A bar complement cross Y bar, okay. So, that means what we are doing, we are using the information of rule 1 and we are finding this consequent B bar dash using this A bar dash composition with R bar. So, this composition you know, we can use max mean, max product, okay, you can use max mean or max product. And why it is called approximate reasoning? This is a reasoning actually. So, why it is called approximate, that I will tell later. First of all, let us take one example and find what you are getting, okay. So, if you have understood this, so next I will write one example, and the example is the previous one where we have already R. You see your notes, you have A, B and R bar, okay. Previous example that I am writing here, and I will give you A bar dash, you will find B bar dash, Okay. So, let us write, suppose it is given a bar dash is equal to 0.5 by 1, this is Jad's notation, 1 by 2 plus 0.3 by 3 plus 0 by 4. Okay? 1, 2, 3, 4, and we have the membership values as 0.5, 1, 0.30, and we were having this relation matrix as 1, 1, 1, okay? 0.4, 0.4, 0.6, 0.6, 0.4, 0.4, 0, 0.4, 1, 0.8, 0.3, 0, 0.8, 0.8, 0.8, 0.8, 0.8. Okay, it was the relation R. Now find from here the consequent B bar dash using max min. Find B bar dash, that we have already discussed, using this R bar and this A bar dash new, this is new antecedent. A bar dash I have given new antecedent. Earlier we had AB, from AB we have generated this R relation matrix. Now this is your new antecedent. Find this consequent B bar dash using max min composition. Okay. Okay, so I have to find B bar dash as A bar dash composition R bar. Okay. What is the order of this R bar? 4 by 6. This is A bar dash O R bar. A bar dash is this. If you write it as column, so what will be the order? 4 by 1, and it is 4 by 6. Can you operate? No. That is why I have to write this as row, means 1 cross 4. Then we can operate 1 cross 4 and 4 by 6. 4 cross 6, we will get 1 cross 6. Okay. So, if we write that, so B bar dash I can write, okay, as 0.5, 1, 0.3, 0, and this relation matrix. Okay, relation matrix is this. Now, suppose after this operation you will get this as what? You will get this is your 1 by 4, this is your 4 by 6. Okay. So, you will get 1 cross 6. Okay. Suppose this B is B11, B12 up to B16. Okay. Now, each B11, B12 etc. I should have max min. So, first this B11 will be maximum of, now see this we have to operate with this minimum, means I have to take 0.5 and 1 minimum, that is 0.5, 1 and 0.4 minimum is 0.4, 0.3 and 0, 0, 0 and 0.8, 0, 0 na? 0. So, maximum is 0.5. Understood? Again I am doing the next one, then it will be clear. So, now this is your B1. Now, B12, B12, B12. So, remember this is here, okay, this row, and this matrix is here. Okay. You have done this as you multiply, matrix multiplication, this into this you do na, you will get first element. Here what we are doing, in place of multiplication you are taking minimum of each combinations, these are these, then among these you are taking maximum. Now, if I want the second one B12, what I have to do in multiplication, this into second. So, I have to now write B12 as maximum of, see 0.5, 1 minimum, so it is 0.5, 1, 0.4, so it is 0.4, then 0.3, 0.4, 0.3 and 0, 0.8. that is 0. Understood how it is got? So, now maximum among these is 0.5. Understood? Like that I can have B13, B14, B15, B16. Okay? So, B13 will be this and this, B14 will be this and this, B15 this and this, B16 this and last one. So, you will get maximum of all those. So, then you will get B bar as B bar dash at first two elements are 0.5, 0.5 and whatever you get. Okay, whatever you get that. Okay? Clear? So, this way you can have max mean and similarly you can use max product. The idea was to have your consequent from rule 2 using the information of rule 1 where it is given if A then B. If A then B, you have created your that relation matrix and from relation matrix new antecedent you operate that by composition and get your new consequent. So, like that you may have different rules and you can have actual system, you can have those things. Okay? So, this is the okay. So, now you take another example, that is an important example. So, there actually you will understand why it is called approximate reasoning. Suppose I have been given one problem. Suppose I denote weak soil by fuzzy set W bar and this is given as 1 by 0 plus 0.9 by 50 plus 0.3 by 100 plus 0 by 150 plus 0 by 200 and this is in capital X. Okay? And medium soil, we denote this by M bar and this is given as 0, 0.4. So, this is given as 0, 0.41, 0.40 and where actually these 0, 50, 100, 150, 200 are actually Y. Okay? And one fuzzy set output and you have these are suppose different antecedent W and M bar, W bar and M bar and we have one fuzzy set as stable and we denote this by S bar and this is given as sorry this is not Y, both are in X. Okay? Sorry. Where X bar is your 0, 50, 100, 150, 200 and Y bar is the same 0, 50, 100, 150, 200. So, these two are in capital X universe. Both are same means both are antecedent in X bar, not same. This represents weak soil. X bar universal set is elements are same, okay, but the set weak soil are having the membership values as 1, 0.9, 0.33, 00 and when we have medium soil then I have the membership values as 0, 0.41, 0.40. These are two antecedents. Remember this is X, this is X, this is in Y. So, now if I write if weak soil then not stable. Suppose I want to construct a building. Okay. Soil is your weak soil, strong soil, medium soil. So, if it is weak soil then naturally it will not be stable and you have to take different precautions. Okay. So, let us have that rule as if weak soil then not stable. If weak soil then if weak soil then not stable. Yes, if weak soil then not stable. I can write this in the form of implication. If weak soil, then not stable, that means W bar implication S bar complement. Understood? This I can write as W bar imply S bar complement. This is done. Okay? If weak soil, then not stable, its complement. And this information I can have in terms of relation matrix. Relation matrix, because you see here W bar is in X, S bar and S bar complement will be in Y. Okay? So, I can have your R bar. R bar will be what? W bar cross S bar complement union W bar complement cross Y. Okay? So, you will get one relation matrix. First you find that relation matrix, then we will again proceed, because see our aim is here the approximate reasoning. I have the rule 1 like this. I want to use this information from rule 1 for the rule 2, maybe for medium soil what will be about the stability. You are understanding? Their antecedent, next rule antecedent is suppose medium soil, that means M bar, and I will use the information of rule 1 as a matrix R, and I want to have the stability. You are understanding the usefulness. So, find this R for this implication first. Okay, see, so we have to first find W bar cross S bar complement. Okay, then you have to take union W bar complement cross Y. This is the procedure, and so I have to find W bar cross S bar complement. So, W bar is your 1, 0.9, 0.3, 0, 0. Is it okay? This is your W bar, and this cross your S bar complement. For 0 it is 1, 0, 1, 0.5, 0.1, 0. So, this is your 5 by 1, this is your 1 by 5, so you will get 5 by 5. Okay? What we have to do? 1, 1 minimum, this 1, this 0.5, then 0.1, then 0. Okay? Next row, what? 0.9, then 0.9, then 0.5, 0.1, 0. So, like that you can find, and this is your 5 by 5 for this is your W bar cross S bar complement. Is it okay? Similarly, you can find what? W bar complement cross Y. So, W bar complement will be 0, 0.1, 0.7, 1, 1 in the row, 0, 0.1, 0.7, 1, 1. Okay? This is your W bar complement, and Y is what? Y will be what? Because it is the universal set. So, it will be all 5, 1, 1, 1, 1, and again it will be a matrix of 5 by 5 order. So, I have W cross S bar complement, W bar complement cross Y. So, when R I will find, I will take union, that means maximum of each elements from these two matrices, that will be your R. Okay? Let me write the R directly. R is your 1, 1, 0.5, 0.1, 0, 0.9, 0.9, 0.5, 0.1, 0.1, 0.7, 0.7, 0.7, 0.7, 0.7 and other? No. This is your relation matrix for if medium, if what is that? If weak soil, then not stable. This is your if weak soil, then not stable. Okay? From this you have generated this R. Now take if medium soil, then what is the your consequent. Okay? So, you have the medium, now you find what? Medium means M, I have denoted na M. So, M bar dot R bar. Okay? Okay? So, this will be what? Yes, correct. All will be point and this is a one row vector. Is it okay? So, this way I can have the consequent using the properties of those that means that rule 1 relation. Okay? Now, here you can see from this actually idea of inverse relationship comes, inverse relationship, because if you remember the last example where we wrote A, B etc. and we find R, okay, we found R, then from that means if it is possible, then you can say that from if A and B I am finding R, what about if I write B is equal to A composition R, suppose these are fuzzy set. Understanding? I am telling from rule 1, okay, that intelligence of rule 1 you are using to find the consequent of rule 2. But why not if you are from the rule 1 you have A and B or A bar and B bar, you find relation matrix there. Okay? If A then B, so you have relation matrix there. Now, if I again take composition of the original antecedent A bar with R bar, why not we will get B bar? Okay, let us check that. If you from the previous example you have R bar, okay, you have A bar, take max mean composition and what B bar you are getting, whether you are getting or not that. Let us see. So, what I told that in the previous example you take A bar, B bar and R bar we have generated. So, there we have generated this R bar was 1 1 1 1 1 6 na 1 0.4 0.4 0.6 0.6 0.4 0.4 0 0.4 1 0.8 0.3 0 and 0.8 0.8 0.8 0.8 0.8 and 0.8. You are given A bar as 0 0.6 1 0.2. Okay? So, this R you have obtained by A to B. A to B, that means A cross B union A bar complement cross Y. Okay? You have got this R bar. So, as per your that approximate reasoning method, now I want that B bar also it was given. So, B bar should be A bar composition R bar. But if you do this operation A bar, this is your 1 by this if I have to write in column. So, I have to write this as what? Column on row? Column or row? Row, because otherwise we will not get that. So, I have to write this as row 1 by 4, 1 by 4, and this relation matrix is your 4 by 6, 4 by 6. Operate that using max mean. Max mean already we have done max mean. So, you will get a row vector as 1 by 6, and that is you are getting what? 0.4, 0.4, 1, 0.8, 0.4 and 0.4, and you can check that this is not equal to B bar. Okay? Okay? That B bar we had taken for generating this R bar. Why? Because inverse is not possible, means this is giving approximately. Okay? Now, this is for fuzzy. You can see the classical one, classical logic also we have done some example. There if you find B is equal to A composition R, it will be exactly B. Let us do that again. For classical logic, we had given this, that example also I did. I had given A as, now this is for classical logic, A as 0, 1, 1, 0, and if you remember in your notes you can see R was 0, 0, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 0, 0, 1, 1, 0, 0, 0, 0, 0, 0, 1, 1. This is your R that we have done. B was given. So, here you see classical, that means all entries are 0 and 1, no partial truth, either true or false. So, now we can find B is equal to A composition R and see what you are getting. See what you are getting. So, if we take now max mean composition for this classical case, so you are having A this, R matrix this, and after taking max mean that I have already explained. So, you will get 0, 0, 1, 1, 0, 0, and you can check this is equal to your given B, because inverse is possible in case of classical set theory. Okay? But in fuzzy you are seeing that it may not be is equal to your that previous consequent B bar dash. Okay? So, thank you.